Hello, I'm Tiana, and this presentation is on the Milky Way, the space race Skylab, and other galaxies, which covers pages 60 to 69 in the resource guides. A galaxy is an enormous collection of matter, including stars, gas, dust, and black holes that are all held together by gravitational attraction. Our galaxy is called the Milky Way galaxy, which is estimated to contain around 100 billion to 400 billion stars. If we could look at the galaxy from somewhere far in space, it would appear as a spiral pinwheel. This type of galaxy is called a spiral galaxy. The galactic disk is a flattened circular region that contains most of the galaxy's stars and matter. The galactic bulge is the thick distribution of gas and stars near the center of the galactic disk. Both the disk and the bulge are surrounded by the galactic halo, which is a spherical region containing fainter and older stars. This diagram shows the different parts of the Milky Way galaxy. And the Milky Way galaxy is rotating in space around the center of the galaxy at a speed of 563,000 miles per hour. Many stars move in star clusters, which are groups of stars that were formed from the same parent cloud and stayed together by gravity. Loose, irregular clusters are called open clusters. Stars in open clusters are usually young, hot, and luminous. Some stars belong to globular clusters, which are located in the galactic halo. These contain around 100,000 to 1 million tightly packed stars each. It is estimated that all known globular clusters are at least 10 billion years old. Some of these clusters contain blue stragglers, which are hot, blue, highly luminous stars. The interstellar medium is the matter between the stars. This serves as the raw material to make new stars and new planets. It is about 99% gas and 1% interstellar dust, which is really tiny solid particles. A nebula is the concentration of gas and dust in space, and an emission nebula is a cloud of ionized gas that glows by absorbing and then re-emitting starlight from hot and young stars nearby. Mapping our galaxy. So it's pretty difficult for us to see more than 1,000 light years away because of the dust clouds in the interstellar medium that absorb light in the visible spectrum. So instead, we use radio, infrared, and high energy waves, which can pass through these clouds and map our galaxy for us. The structure of the galaxy can be mapped by detecting radio waves with a 21 centimeter wavelength. The 21 centimeter radiation is emitted by neutral hydrogen atoms. Radio astronomers map the densest gas concentration by looking at the emission of tracer molecules, such as carbon monoxide, water, and formaldehyde. Detections led to the discovery of Sagittarius A, or Sag-A star, which is a black hole in the center of our galaxy that compresses and heats matter, producing the observed X-rays. Walter Baade classified stars into two classes, population 1 and population 2. Population 1 stars are the hottest, most luminous, younger stars, typically. They're usually located in the disk of the galaxy, and they are high in heavy elements in addition to hydrogen and helium. Population 2 stars are typically older, and they are found in the galactic nucleus and halo. Some are found in globular clusters, and they are made of almost entirely hydrogen and helium. Astronomers use the age of star clusters to estimate the age of the galaxy itself. The Milky Way galactic disk is at least 10 billion years old, and the galactic halo is believed to be 13 billion years old. Astronomer Vera Rubin showed that stars only make up a fraction of the mass in a galaxy like the Milky Way, and most of the matter is dark matter. The current hypothesis of the formation of the galaxy is that a cloud of cosmic gas spread over an irregular region of space. Rotation of this cloud caused gas and dust to contract and form a spinning galactic disk, which flattened over time, and the older stars remained in the halo, whereas new stars formed in the galactic disk. And here's a picture of Vera Rubin. So now I'm going to talk about the Skylab, which is part of the space race. Skylab was the first American space station, launched in 1973. Astronomers aboard Skylab conducted research in solar astronomy, biology, and material science. This space station was a landmark to investigating the effects of spaceflight on humans. Skylab demonstrated that astronauts could live and work in space for months at a time. In 1979, financial constraints in the creation of the Space Shuttle program led to the end of Skylab, which ended up disintegrating and it fell into the Indian Ocean. The mission itself lasted less than a year, but this was a crucial step in space research laboratories such as the International Space Station. The Hubble classification scheme uses 4 different types of galaxies: elliptical, spiral, barred spiral, and irregular. Elliptical galaxies have no disk or spiral arms and little visible gas or dust. They're mainly composed of old, reddish, low-mass stars. Spiral galaxies, like the Milky Way, are disc-shaped with spiral arms and a central bulge. Barred spiral galaxies are similar to spiral galaxies, but the spiral arms unwind from a bar-shaped concentration. Disc-shaped galaxies with no spiral arms are called lenticular galaxies. Irregular galaxies have no regular shape or structure. They usually contain gas, dust, and mainly younger stars. The distance to a galaxy is important because it can help determine the galaxy's properties. Galactic distances are typically measured in megaparsec, which equals 3.26 million light years. Astronomers can approximate the distance to galaxies by using standard candles, which are objects of a known brightness that can serve as a reference for distance. When the magnitude of the standard candle is known, the distance to that standard candle can be measured by comparing the absolute magnitude with the apparent magnitude. This can be used to estimate the distance to the object that the standard candle is near. A galaxy cluster is a group of galaxies held together by gravitational attraction. The Milky Way belongs to a small cluster called the local group with about 40 galaxies. Most of these are dwarf galaxies or small galaxies that are only a few thousand light years in diameter. Clusters can be either regular or irregular. Regular clusters are compact with a high density near the center. Irregular clusters, such as our local group, have a loose structure with little concentration and less hot gas. A supercluster is a cluster of clusters of galaxies. These are the largest gravitationally bound systems that we have observed, and they are located in thin sheets that border voids, which are regions where few galaxies are located. Galaxies can collide and pass through each other. This causes an increase in star formation, causing a starburst galaxy, which is a galaxy in which stars form at a much faster rate than in our galaxy. Galaxy collisions can dramatically change the structure of the galaxies, but they usually have no effect on the individual stars. It is also possible for a very large galaxy to consume a small galaxy in a process called galactic cannibalism. And this usually happens when the masses are very different. Active galaxies are galaxies that emit large amounts of energy in the form of radiation. The center of one of these galaxies is called an active galactic nucleus, which is the source of the galaxy's exceptional output of energy. The source of energy for an active galaxy is a powerful source of gravity, such as a giant black hole. And one type of active galaxy is called the Seyfert galaxy. A radio galaxy is an active galaxy that emits large amounts of radiation in the form of radio waves. The radio galaxy typically shows 2 large regions of energy at radio wavelengths called radio lobes, which are on opposite sides of a visible galaxy. This pattern is called synchrotron radiation, which is radiation produced by electrons spiraling around at a very fast speed in a strong magnetic field. Quasars are distant sources of radio waves that appear as stars. They have extraordinary power with a variety of wavelengths. Quasars are very compact. They are only about 1 light day apart, but they shine brighter than 100 normal galaxies. They have the highest redshifts observed, which indicates that they are racing away from us at very high speeds. Observations show that they are extremely far away, and there's evidence that quasars are powered by a supermassive black hole. Quasars can be observed using a gravitational lens, which is a concentration of mass that bends the path of light emitted by distant objects. Galaxies, interstellar gas, or dark matter can act as a gravitational lens. These allow us to get images from objects that are too faint to examine. That's all for my presentation. Thank you for watching.